Good morning, everyone. Today is Monday, March 16th, 2020, and it's our first e-learning day. We are starting a new module today. It's another brief module like the last one on sequences, module 7. Before you start this video, you should have printed out the notes so you can fill things in as you go. I thought we might just need a little fun in our week, so here's our theme days for this e-learning week. Today is, these are just Mrs. Anshek's theme days. Monday, pajama day. Hope you're celebrating today in your jammies. Tuesday, go green. You don't need to be Irish to participate. Wednesday, let's make a jersey day. Kind of a nod to all those athletic teams that have been canceled. Thursday, workout day. Time to get off the couch. Put on some athletic gear. Get outside. And Friday, of course, Hawaiian day. Happy spring break. I'll remind you again before we leave. Hopefully you can participate with us this week on our theme days. Alrighty, let's get rolling. Again, you printed out your notes. We're talking about sequences this week in Module 7. A sequence is simply a pattern of numbers. For example, if you looked at that pattern and I asked you to identify the next term, we call it, in that sequence, please jot it down. And you should have found the next term in that sequence is 1 over 6. We're going to look at this one in detail in a second. Find the next term in this sequence. Look at it for one moment. And you probably saw the next term in that sequence in that pattern of numbers would be negative 12. We're going to come back to that one when we turn the page. Sometimes we can represent a sequence, a pattern with a function. You might recognize this. Back in the day, we would have said that f of x is equal to 1 over x. We used to call that the reciprocal function, if you remember. And if you graph that reciprocal function, f of x, it looks something like this. It would have also been in the third quadrant down here for that reciprocal function. But if we represent that sequence, that pattern, sometimes with sequences, we use the input of n, 1 over n, because for sequences, our inputs are always integers. For n, some integer. And we use the positive integers, 1, 2, 3, all the way up to infinity as our inputs into sequences. So when I input 1, 1 over 1 is 1. When I input 2, 1 over 2 is 1/2. When I input 3, 1 over 3, my output is 1/3, but I would not connect those dots for a sequence. We used to call this a discrete function back in Honors Math 1. I don't plug in anything in between, just those positive integers for a sequence. A sequence is usually represented by listing several of its terms. We call them in order. We typically use subscripts when we talk about the terms of a sequence. So a sub 1, we say, for that sequence, I plug in 1, I get 1 over 1, which is 1. When I input 2, my output is 1 over 2. Notice the input is the subscript. A sub 3 is 1 over 3, and so on, all the way up to a sub n, the nth term of that sequence, is 1 over n. So again, notice that the subscript is the input into a sequence. Alrighty, let's move on just a little bit. When it's possible to find a formula for the nth term in a sequence, the nth term of a sequence is sometimes called the general term of that sequence. This would be the general term of that sequence in terms of n. If you can find a general term for a sequence, then you can represent the entire sequence for that term. Let's look at a new sequence. Let's say my sequence is a sub n equals negative 2n plus 3 for some new sequence, a sub n I'll call it. Find the first 5 terms of that sequence. That means my first term, I input 1, negative 2 times input 1 plus 3. The second term of that sequence will be negative 2 times input 2, that subscript, into that given sequence, the general term. What is that? Negative 2 plus 3, which is 1. Negative 4 plus 3, which is negative 1. I'm going to pause here so you can find the third term, fourth term, and fifth term of that sequence. All right, check your work. Again, your subscript is your input. Input 3, you got negative 3. Input 4 for n, and you got negative 5. Input 5, and you got negative 7. If you ever make a mistake, you can pause and fix your mistake. Let's look at a more complicated sequence. I'm just going to call this sequence S sub n and find the first 5 terms of that sequence. So if I find the first term, I'm plugging in 1 for n, which is negative 1 raised to the 1 plus 1 times 1 squared over 1 plus 1, just a more complicated sequence. What's that? Negative 1 squared, which is 1, times 1 over 2, and my first term is 1/2. Second term, negative 1 raised to the 2 plus 1, times 2 squared over 2 plus 1. Negative 1 to the third is negative, so that's negative 1 times, what is that, 4 over 3? And I get negative 4/3. I'm going to pause, and you can pause, and just find the next 3 terms of that sequence. All right, and check your work. For S sub 3, I got 9/4. For S sub 4, I got negative 16/5, and S sub 5, 25/6. If you disagree, check any of your signs and work in that, and all of your work. Sometimes we call this an alternating sequence because it's alternating from positive to negative to positive to negative, and so on, as we turn the page. Watch for that. Alrighty, we like it when we can come up with a general term because then we're able to find any term of that sequence. Here's a new sequence, if you can start to find a pattern for this on your own. So this is, I'm going to call it a sub n for my general term. Watch this. When I plug in 1, my input, I get 2 over 3. But when I plug in 2, my input, I get 4 over 9, and so on. Plug in 3, plug in 4, I get 16 over 81. See if you can find a general term, a general pattern for that sequence in terms of n. When you plug in n, you have to get that term number. Pause and see if you can find a pattern for that sequence in terms of n. All right, thanks for trying. You may have noticed that's 2 to the first, 2 to the second, 2 to the third, 2 to the n. Denominator is 3 to the first, 3 to the second, 3 to the third, or 3 to the n. If yours doesn't look just like that, there's other ways to write that. Some of you might have said 2/3 to the n. So sometimes they look a little different, but do the same thing. Here's that sequence we saw right at the start. All right, try this one. I'm going to call it b sub n. It doesn't matter what I name my sequence. So b sub 1 is 2. When I plug in 2, I get negative 4. When I plug in 3, I get 6. When I plug in 4, I get negative 8. When I plug in 5, I get 10. Pause for a second and see if you can find that pattern. Plug in n and you get that term. Pause again. All right, you may have noticed that this is an alternating sequence, positive, negative, positive, negative. You also probably noticed when I plug in n, I double it, double it, double it. Plug in n and double it. What makes that sequence alternate? We use this cool trick for alternating sequences. Negative 1, watch this, raised to some power. If I raise negative 1 to the nth power, negative 1 to the first is negative, times 2 would be negative 2. I don't want it to be negative. Negative 1 to the second would be positive, times 4 would be positive. I don't want it positive, so I'm going to use this trick. And that should describe that sequence. The nice thing about an explicit sequence, which all of these is, I can find an explicit formula. If I asked you to find the 100th term of this pattern, you could. That would be negative 1 raised to the 100th plus 1 times 2 times 100, which would be negative 1 to the 101st, which is negative, times 200, which is negative 200. So that's the nice thing about these explicit sequences. Again, for this alternating pattern, we usually use one of these tricks, negative 1 to the n, or negative 1 to the n plus 1. Here's a tricky one. I'm going to call it a sub n. See if you can come up with a general term for this pattern. Plug in 1, I get 1, but I plug in 2, I get 1/2. Plug in 3, I get 3. Plug in 4, I get 1/4. What makes that alternate between integer, fraction, integer, fraction? I'll pause again while you look. All right, you can take as much time as you need, but this is a tricky pattern. All right, what makes me alternate between integer and fraction? Some of you can write this pattern this way. Plug in a number, and then I'm going to raise that to a negative power. The problem is for that first one, I want, or I should say for the odds, I want an integer, so I don't want to move it down. So I'm going to raise it to an odd power, but I don't want the odds to move, so I'm going to actually raise it to the +1 power. So that's -1, let's test it first, n equals 3. -1 to the 4th, which is positive, plug in 3, and I don't want a fraction, so that works. Or some of you like this, 1 over n, and let's use that negative power to move it up or down. Now I want the evens to stay fractions, evens to stay, so I'm just going to raise that to the nth power, and then my evens should stay. Plug in 2, that's positive, and I get 1/2. Okay, so that's a trickier pattern. Again, all of these are explicit patterns when you can find an explicit formula to describe the nth term. Do you remember the term recursive? Recursive formulas back in Honors Math 1, or a recursive sequence, is always defined in terms of that previous term number. So let's see, this is an example of a recursive sequence. Tell us where to start. The first term is a sub 1, and then this tells us what to do next. The next term, a sub 2, is defined in the terms of the previous term. The term right before a sub n is a sub n minus 1. So my second term, this definition, it's just a made-up formula for a recursive sequence. Plug in the term number minus the previous term. It should be 1 minus a sub 1. In this case is, plug in the term number 2 minus the previous term, 2 minus 1, which is 1. To find the third term, plug in n, subtract the previous term, which is a sub 2, which is 3, minus, we found a sub 2, which is 1, which is 2. In a recursive sequence, each term is defined in terms of a previous term. Pause and find the next two terms, please. All right, so the fourth term is plug in 4 minus the previous term, 4 minus 2, which is 2. Fifth term, plug in n for that definition, minus the previous term, and I got 3. Here's one to try. Recursive uses a previous term in its definition. So here's the sequence of numbers, -7, -13, -25, -49, and that pattern continues. Could you write a recursive definition for that sequence? Recursive means tell us where to start, and then all other terms are defined in terms of a previous term. I'll pause and see if you can find that pattern. All right, any luck? Recursively, tell us where to start, -7, and then how do I find the next term? I noticed I take this and double it, but then I have to add 1. Take this and double it, but then I have to add 1. Take the previous term, a sub n minus 1, double it, but then I have to add 1. And that's a recursively defined sequence. The problem with recursive is finding a sub 100 is very hard. You'd have to know a sub 99 and move backwards. So it's a little bit less convenient. A famous sequence, a recursively defined sequence, is a Fibonacci sequence. If you have a moment and you're sitting on your phone today, Google it. Watch a couple YouTube videos on the Fibonacci sequence. It's an interesting sequence pattern. If this is the Fibonacci sequence, could you find the next few terms of that sequence? Look at it for a second. The Fibonacci sequence does this. It adds the 2 previous to find the next term. Add the 2 previous to get the next. Add the 2 previous. Add the 2 previous. You get 8. Add the 2 previous, you get 13. Add the 2 previous, you get 21, and so on. It's a famous pattern. I don't know if you could write a recursive sequence to describe that. It's a bit challenging, but you could give it a go. I'll give you a second. There are options, but sometimes we describe it this way. First term is 1. Second term is also 1. After that, what do? We take the previous term and add it to the term before that. That's kind of a tricky one. But again, it's an interesting sequence if you have time to look it up today. All right, thanks so much for watching. Your assignment tonight is worksheet 7.1, numbers 1 through 14. Be prepared to send me some sort of photo or something of your homework tomorrow. and you're going to finish that worksheet tomorrow. And I'll ask you how, or tell you how you can turn that in also. All right, thanks so much for watching. We're out of time.